SID and then you just put in case. And I'm going to wrap this on new lines. You don't have to, but it always looks better when you're writing something like this. And then for each case label, you do when, and then a condition, then, and then a value. So this is kind of like in a switch statement. If you did, switch on whatever, case 5, and then after that you would do something like return X or hello or whatever. So I want to do when grade equals A, then superior. Okay, and then there's no comma or semicolon or anything, and then it's just the next case. When grade equals B, then good, and so on. And then when you're done with the cases, there's the keyword end. Okay, so I'm selecting 2 columns. I'm selecting SID, and this entire thing turns into another column. So what am I selecting from? You still need that. So select all that from enrolled. Okay. Now the formatting is all weird looking because if I scroll up here, the name of that column, it doesn't know what to name it, so it just names it the entire case. So what we want to do is after the end, just rename it. So I'll name it as remarks. Okay. I'm getting some nulls in here because let me go back to just the entire enrolled data. All I put in was a case for A and a case for B, so anyone who has anything other than that, including an A minus, just turns into null. So you can do, keep it down over there, please. You can do similar to a default. It's not called default though, it's just else. Then we'll call it, I don't know, other. Okay. Now, a quick little quiz for you. So this is one of Hermione's grades. She certainly did not receive a C or lower. It's coming from that right there. So quick little quiz for you, not related directly to switch statement or case statements in SQL. How would I turn that into a superior? So A minus or A is superior.
You can do like A asterisk.
Yes, so sort of. So this A star. Right. Yes, right idea, but not the syntax for SQL.
Do you say like?
Yeah, so we need to do word grade like, and then it's not an asterisk, it's a %. But yeah, exact same idea. So, and there you go. Okay. Yeah.
So if you're doing something like switch case where you're assigning a number, will it be 0 or instead of 100%?
So if we were using numbers instead of strings?
Oh, else. Okay.
Yeah.
You would just define it.
If you leave the else off, then anything that doesn't match one of the cases will turn into null. But remember, don't think of null as null in your head. Think of it as unknown. So it's not actually 0 like it is in a programming language. It's some unknown value. Okay, here's another interesting property of how these case statements work in SQL. So let's look at the students now. Do another little example. Let's say I wanted to label these as like freshman, sophomore, junior, or senior based on their age. So, you would do something like if their age is 18, then they're freshman. 19, then they're sophomore, and so on. So you could do, so I won't even write the whole thing out. I'll just do, select something, case, when date of birth is, so you could do when date of birth is equal to, let's see, ignore the actual dates of birth in the table. They were like born in the 80s or something. So a freshman today would be born in 2001, I think, right? So when date of birth equals 2001, then freshman. Okay. But this, so what about people that were born, so what about like so-called super seniors? We don't want to call them super seniors. What about people that are older than that? We don't want to use an exact date comparison like this. So I want to say anyone born in 2001 or later is a freshman. So I'll do greater than or equal to 2001. And what you would really want is though something like and date of birth less than or equal to current date or something. But you don't need to do that. We can just do when date of birth greater than or equal to 2001, then freshman. When date of birth greater than or equal to 2000, then sophomore. And you could just keep going. So even though anything greater than or equal to 2000 is also greater than or equal to 2000, or sorry, anything greater than or equal to 2001 is greater than or equal to 2000. It evaluates the cases in order. So as soon as it hits one of them, it'll stop. And you're not going to get the problem of it will report like freshman and sophomore, even though you're not doing the full range comparison. You don't have to say like between these two dates. You can just say anything greater than this date first. Then, if that was not true, anything greater than like 1 year earlier. So I won't, this isn't a real query, but it does work that way. It'll stop as soon as it hits one. It's tempting to confuse these with switch statements or confuse how they work with how switch statements work. Just keep in mind it's only kind of similar. Like there's no break. It's else instead of default, but no break is the biggest like functional difference, which is why this works. You don't need a break on any of them. If you left off break in a programming language switch statement, then you could sort of get two of these things, two cases hit for one value.
So you do like math inside the range statement?
Can you do math? Yes. So if I had like when date of birth, so you could do something like when 2020 minus date of birth equals 19 or whatever, something like that. Yeah. It's just any, so it goes when, and then any condition, and then then. This command's not going to work. I'll just close it with a semicolon and get an error. So slides is kind of covering that, just there for your purposes for later. With case statements in particular, you almost always want to rename them. So otherwise, you get this really ugly column name. This is the exercise we just saw. The shortcut way to do it is taking advantage of the fact that the cases are evaluated in order. Okay. So moving on. Question. Let's say we want to return all of Joe's books in the library database. So return just means, here's the library. What does it mean for a person to have a book? Like what would that mean in this database? How is that represented? There's a row in the checked out table. So to return a person's book, we would want to remove rows from the checked out table. If we wanted to return all of Joe's books, then we would need to remove all of the rows in checked out corresponding to Joe's card number. Okay, so this is easy so far. I mean, we know how to do this. I have a copy of the library here in the sandbox because we're going to be messing with it. So let's do select star from checked out, select star from patrons. So we know that Joe's card number is 1. If we wanted to remove all of Joe's books, we could do delete from checked out, where card num equals 1. But what's the problem with this? What's this called? Query by instance. Yeah, we do know that Joe's card num is 1, but we don't always know that. We only know that because we're looking at this particular instance. So what we've done some very simple insert and delete stuff, and it's always been pretty much like this, where if we did anything, it was probably query by instance. So what we need is some kind of dynamic delete query where we are deleting where the condition is not a specific card num. The condition is, we'd have to go and join with the patrons table and search for the name Joe. So, so this is just again saying what return means is delete rows from the checked out table. We can't do it by query by instance. So how do we know which ones to delete? And it's easy. You can put where clauses on delete, as we've already seen, but you can use all of the normal operators. You can use nested queries in there. You can use in, exists, greater than any, after that where clause on a delete. So, and you can even use equals. So we will see. Let's formulate it that way. So instead of where card num equals 1, we know we can do that. But you can use the equals operator on a nested select. So we'll do where card num equals select card num from patrons where name, capital name equals Joe. Okay, so this was not a select query, so it just ran and did something. If I go back to select star from checked out, Joe's books are returned, so they're available for someone else.
Does it give you any kind of feedback you can see that this completes successfully, just deleted 1 row? Like if there's multiple Joes, it could delete 500 rows.
It does give you feedback. I unfortunately have a setting set where it does not tell you how many rows were affected. You can just change that and it will tell you, yes. It would have said 2 rows affected.
Can it tell you anything else besides the number?
It can tell you warnings. It can tell you, yes, so it mostly tells you number of rows affected and how many warnings there were. We'll actually see warnings later today.
What happens if the inner select produces more than 1 row? Is it just picks the first one?
Great question. So what happens if the inner select produces more than 1 row? So if I did where name equals Joe or name equals someone else or something like that. This actually isn't an example of it because Ben has no books checked out. But what it would do, so let me see if I can actually show an example of that. So let me put back in, let's put in a book for card number 2. Hope I can pick a random serial number that's not already checked out. Okay. So I start from checked out. So we have one by card number 2 and card number 4. So who are they? Anne and Dan. So let me go back to this query. From patrons where name equals Joe or name, or sorry, we want Dan, or name equals Anne. Error, subquery returns more than 1 row. So what's going on here is this equals operator. Equals comparison doesn't make any sense when you're trying to compare one thing to multiple things. So you just can't. The subquery has to return one row. But what if we did want to delete all of the checked out books for Dan and Ann?
In?
Yep. So we would just do where card num in. So you can use in, not in, exists, greater than all, anything like that.
Is there something like delete all from checked out where card num equals?
Delete all from checked out where card num equals. So, I mean, yeah, you can just do. So delete all from checked out. You mean just remove every.
Or where it, like on the condition, delete all where it matches that condition, or is that just more less efficient than doing
Delete all. So let me go back to this. So this query here will delete all where the card num matches the name Joe.
Oh, okay.
It's just the inner select there only. The inner select only returns one row, but there will be multiple rows from checked out that match that card.
Right.
So we'll delete all.
So what happens if the inner select is empty? In that case,
If the inner select is empty, it will do nothing.
Deleting all except.
So deleting all except Joe's, we would do where card num. You could do not equal to, or you could do not in. Okay.
can you join tables and then delete rows?
Can you join tables? Actually, yes. Good question. So what if you need to? We don't need to do a join to do this query, but sometimes you do need to do a join. So let's try to formulate this in a different way. Delete checked out from checked out. Delete from. Actually, I'll backspace the whole thing. Delete from. So one way of getting Joe's card num is patrons natural join checked out where name equals Joe. Well, let me fix the syntax here. We would want delete from what? Delete from checked out, natural join, patrons, new line, where name equals Joe, something like that. Problem is, look at what I'm deleting from. I'm deleting from a temporary table, which you can't do anyway, but even if you could, it would have no effect. Like, what does it mean to delete something from a temporary table? It's useless. But you can actually do this. It's just the syntax is slightly different. So just kill that query again. I can't wrap it onto a new line if I want to be able to go back. Where name equals Joe. So all you do is you say delete checked out from checked out natural join patrons. Syntax is a little weird. All you're doing here is you're specifying. Okay, so this here, this join is a temporary relation where it's matching one row from checked out and it's matching one row from patrons. So what this is saying is, I want to delete the corresponding row from checked out that matched the row in that natural join. So if you want to delete the patron value, then you would do delete patrons from checked out natural join patrons.
If you do, like, let's say you have like 4 joins and you want to delete 2 of those tables, can you do delete checked out, comma, patrons?
Yep. This syntax is less common than just using like a nested query in one of the like in or not in operators. Usually like a more natural way of writing a query.
Can we use left joins?
You can use left. Right, so just kind of slides on what we just did. This doesn't work because you can't delete a row from a temporary table. So you just, this weird-ish syntax saying which table do you want to delete from that has a corresponding row in the temporary table. Okay. Yeah.
What if you want to delete from both checked out and our and patrons, like that person no longer is a member and they did not look back?
Then you can specify both tables.
Comma.
Yeah.
Checked out and comma.
Yeah. So that's dynamic deletion. So what about dynamic insertion? Same sort of thing. We can, all we've really seen with insert is like insert into some table and then some like hard-coded values. Here's an example though. What if we want to check out a book for a patron given a name and given a book title? So the insert we need to do is a card number and a serial number. But what we have is a person name and a book title. So similar thing. We can insert where we need to eventually arrive at a card number and a serial, but we can produce them dynamically. And so the syntax is you can just put a select inside of where the value would normally go. So you normally have insert into table values, and then like x, y, z. X, y, and z can be a select. Except, whatever those selects do, they have to have one row. So you get the same sort of problem we saw where it said subquery returns multiple rows if they didn't. Okay. Yeah.
And they return multiple columns?
Can they return multiple columns? Not if you use, well, if you want to do that, you just use this syntax where, so this is inserting two columns. I think
Right.
with two different
Like,
slides.
let's say you want to return like their card num and then their serial num and then something else.
You can, the syntax is a little different though. So let's work on this. This query we want is insert into the checked out table dynamically, given a patron name and a book title. So first I'm just going to delete everything from checked out, just so we can start with empty. We know all of the books are available for checkout. So insert into checked out values, and then we need something that results in a card num and something that results in a serial number. These things inside parentheses can be selected. So select card num from patrons where name equals. This is where we can put in whatever name we want. So we'll just use Joe. Okay, and then just comma. So next column that we're inserting. Select serial from, if we want the of a book with a certain title, then we need to join two tables. That would be titles, natural join inventory, where title equals something. So let's do Harry Potter. Okay, so that wraps up the second nested select. That wraps up the values that I'm inserting. So let's see what happens. Subquery returns more than one row. Let's see what we have here. So I start from titles natural join inventory.
You have two C's in your select.
So the problem is I have two serial numbers for Harry Potter. That's why that subquery was returning two rows. So which one do I want? Well, we can start by just doing So select serial from titles natural join inventory, where title is Harry Potter, limit 1. Okay, that works. So Joe got a copy of Harry Potter. We know there are 2 copies of Harry Potter, so let's say Dan wants to check out a copy of Harry Potter. Duplicate entry for primary key, because serial number is the primary key in the checked out table, and somebody already checked out that book. So there is another copy available. So the problem is, or the thing you have to solve is, how do I find one of the serial numbers, but one of the ones that is not already checked out by somebody else?
And you need another column in your inventory that says like it's checked out or not.
So do you need another column in the inventory that says it's checked out or not? How do we know, currently, how do we know whether a book is checked out in the library? It's in the checked out table. So, right idea though, we just need to know, we need more information. We could add an additional condition to this, or a join, where we could look at the checked out table. We could do something like where serial not in, select serial from checked out. I'm not going to actually write that out though, because that is very similar to something you'll be doing in Homework 4. But I did kind of basically just give the answer. Here's what I want to show from this though. When I run this query, it's a certain kind of error. This query is syntactically valid. It has to try to run this query. It doesn't know that this query is invalid until it starts running. So it's kind of like the difference between a compile error and a runtime error. This is a runtime error. So to illustrate that more, like what can we do about this? Let's say Joe wants to check, again, leave it at Joe, but Joe wants to check out Dune. Column serial cannot be null because this library doesn't actually have any copies of Dune. So this is just another runtime error another way that a runtime error can happen and cause this query to fail. But it's still a valid query. Like, you might want to try to check out a copy of Dune. If it doesn't work, you don't want it to fail. So when you have a runtime error as opposed to a syntactical error, you can do insert ignore into. This will convert runtime errors into runtime warnings. And it's really unfortunate. I was testing this on with another shell where I did not have that setting where the warnings are disabled. It would say that there's a warning here, but what I can do is show warnings, and it tells me the warning. Normally, right after running a query, it would say like one warning. My shell is not telling me that right now, but you can always do show warnings, and it'll tell you what went wrong. So as we saw, though, the query ran, it didn't produce an error, which is what we want, even though it didn't do anything. So this insert ignore syntax is what we do when we're not sure the query is going to work or not, but we want to try it.
If this is like part of the library application like that, where you are checking out stuff, is there an easy way to get it to tell us enough information that any code surrounding this would be able to tell, oh, there just isn't a copy of Dune, or something like that, and then tell that to the user?
Yeah, so this is maybe not the best example of where you would run this query, because the user, like in a web page or something, they're trying to check out Dune. The web page would probably not even show them Dune in the first place, so there wouldn't be a button for them to click. But yes, you could easily just run another query saying like, well, give me all the books that are available for checkout, and then it just won't even have Dune. Okay. But So that's a good point, though. We're doing all of this in just from the command line. We're eventually going to be writing SQL queries in software, and there is a way to tell whether a query returned a warning or not, same as you can in the command line. Okay. So same sort of stuff we just did, but just slides for archival purposes. Okay, let me recap a little bit on how MySQL or how SQL treats logic. It doesn't use Boolean logic, it uses 3-value logic. So remember what this means is anytime you see null in your mind, that's not that's not like a pointer value or it's not 0, that is one of the logical values. So there's true, false, and null. But anytime you see null, replace it with the word unknown in your mind. That's really what it means. So is 5 equal to an unknown value? The answer is not false. The answer is not true. The answer is unknown. We already talked about this, but just to briefly recap. But here is, and we saw kind of where simple implications of that. Like if you want to know if something is unknown, you can't use equals. You have to use is null or is not null. Here's another little example. Let's say I have like a scores table for some class. So instead of a letter grade, this is like their total weighted course score. And whoever designed this database decided to represent the extra credit portion of the score in another column. And instead of using 0, they say they use null. Like that person didn't do the extra credit. And then I want to use a case to convert their score plus extra credit into a letter grade. So score plus extra greater than 93 means A. Score plus extra greater than 80 means B. So I actually have that here. Let's start from scores. So I have, these are student IDs. Some of them did the extra credit, some of them didn't. So if I want to do select SID, comma, case, when score plus extra greater than 93, then A. When, I'll just kind of copy most of that. When it's greater than 80, then it's a B. Okay. And then I'll just kind of wrap it up there. And call it as greater from scores. Okay. So we get Hermione got an A. Whoever this is, Harry, I think, got an unknown, even though 85 is at least a B. Let me actually rewrite this query a bit and do an else. C. So anything below an 80 is a C. And then let me show you again everything from scores. So this is saying that this person got a C, even though they had at least an 85. Clearly that's wrong. This is the problem with 3-valued logic. 85 plus null is not something greater than or equal to 85. 85 plus null is some unknown value. So we give it a C. The way we can fix this, there are multiple ways. We could use like another case to convert null into 0 or something like that. But there's a better way to do this when dealing with nulls. It's this function called coalesce. So coalesce takes in some number of inputs, and all it does is return the first non-null one. So here's kind of just a weird random example. Coalesce null, null, 7, null, 15, gives me 7. First non-null input. Usually not that useful with like hard-coded values like this. Usually more useful with dynamic inputs. So coalesce some value that might be null, comma, what value do I want to convert null into if it is? So what this would do is give me either extra credit or 0 if extra credit was null. So we can fix our query. There's the one that's giving us the wrong C's here. Those people should not have C's. So what we'll do is score plus coalesce extra comma 0. Oops, 0, not parentheses. Am I missing a parentheses?
Yeah.
Yes, I am. And we'll just do it over here. So now nobody has a C, which is correct because everyone had at least an A, even the people that didn't do the extra credit. You could rearrange this query so that you don't have to write coalesce on every case. Like if you did the coalescing first, save that into a different column. But you have to do like another nested select or something.
Does the type of the column influence null's behavior at all?
Does the type of the column influence null's behavior? No. Okay. So this is kind of a bad example because you might just say, well, this was poorly designed, and you should just say that extra credit should not be allowed to be null. It should be 0 if they didn't do it. But, and sure, maybe you could do that. But you can't always do that. Sometimes there are nulls in the tables. But sometimes, even if you redesigned it so that none of the tables are allowed to hold null, sometimes you do still end up with nulls in temporary results. For example, a left join. Remember, a left join gives you everything from the left table and everything that matches the condition in the right table. The things that didn't have a match get null for the columns out of the right table. Let's do like a concrete example of that. I'm going to use the real library now. We won't do any inserting or deleting. I want to select star from checked out. This one has a few more things checked out by various people. Let's say we want to ask the question, how many books does each patron have checked out? So it would be 3 for card number 1, 2 for card number 1 for card number 2, 2 for card number 4. But it would be 0 for this person. So let's start just kind of building this up. Select card num, comma count, star from checked out. So how do we find how many each patron has checked out?
Group by?
Group by. Group by what?
Cardinal.
Card. Okay, good. Except this is not saying that card number 3 has checked out 0 books. So how do we get card number 3 into here? So first I'm going to wrap this whole thing into a temporary query. I'll call it as counts. And I will rename this internal count as count. Okay, so what we need is select all patrons, natural left join. We need to select some columns. So I will select name and counts.count from patrons, natural left join, that whole internal query that we had. Okay. This is wrong though. Ben has not checked out an unknown number of books. Ben has checked out 0 books. This is where nulls can come up, even though there are no nulls in any of these permanent tables. This is why you need to always be aware of 3-value logic, even if you design your tables not to ever deal with null. Sometimes your queries do have to deal with it. So I won't continue this, but as we saw, you can use coalesce to fix it, to turn that null into a 0. Yep.
Is it easier to use coalesce than to make the default of that column 0?
Is it easier to use coalesce than to make the default 0? Yeah, they're kind of solving different things though. So if you can, don't allow the column to be null. So just say not null and make the default 0. But this right here is an example of this null didn't come out of a column in a table. This null came out of a left join, which was just the product of part of the query. So there's nothing we could do in any of the column properties that would prevent that null from ever happening.
Did we just left join first and then just count the serial?
Left join first and then count the series.
So you don't have to have a nested query, a nested select. So you left join patrons to checked out and then divide the name and then count only the serials instead of count star.
Camp doesn't work that way. Okay. So, we've seen a lot of things that SQL can do. You can do all of these things in a program. Like, you can do averages. You can write switch statements to convert one value into another. You can filter. You can sort. MySQL can do a lot of that stuff too. So who should do it? Like you might think, so you're writing a C# program and you have access to a database. One thing you could do is select star from every table, join every table. Then you could go and write your own filters. You could use your own hash tables, do a quick sort, things like that. Problem is, real tables, real databases don't have like 5 or 10 or less rows in them. If you do every table, join every table, you're going to get way too much data to ever transfer over the network. So general rule of thumb is let MySQL do it if it has a natural way of doing it. Not only is it probably already optimized to do it well, certainly programming languages have optimized ways of doing things, but there's not going to be much difference. If you do it in SQL first, then you're reducing the network traffic that you have to send back to your computer that's running the program. Rather than saying, okay, just give me everything from the table and I'll do my own filtering. Let SQL do the filtering and then send way less network traffic. Plus, the way that it runs these queries is quite smart. So it has something called a plan generator. You can kind of think of that as like an optimizing compiler. It'll take your query, usually no matter how you wrote it, and it will optimize and figure out a good way to execute it. Okay?
Is that for MySQL only, or can you assume that other?
This is for databases in general. When you're writing software that interacts with a database, rather than just doing command line stuff, so this doesn't really apply when you're doing command line stuff. We'll eventually start writing software that dynamically generates database queries.
Is the plan generator able to like rearrange case statements? Because like, let's say that hypothetically 90% of your values are null, so would it be better to like account for the case when it's null first, and then account for the cases when it's not?
So does it rearrange case statements? No. It has to evaluate them in the order you specified, because it's assuming that you might be relying on that. However, if you can't think of a way to do what you're trying to do in SQL, then do it in a programming language. Try at least a little bit. Like, there's got to be a way to do this in SQL. Get it at least as close as you can. Return as little data as you can back to the program. Then you might need to do some additional computing on the data. Okay. So I want to do a bit of exam review now. In the interest of time, so just to kind of reset, let's take a short 1-minute break, and then we'll leave more time for the review.
Connected to Wi-Fi?
Do not, if I cover something more thoroughly or less thoroughly here, that does not mean it will be like that on the exam. This is just some interesting things that I have. Okay, so content will be, it's cumulative. Well, obviously it's cumulative. This is the first test. Everything up until today's lecture. So I won't go through everything here, every bullet point here in detail. Read this later on your own time. But I want to kind of emphasize relational definitions. Like, I don't care if you memorize some definition and then regurgitate it on an exam. I want to know if you understand what the definition and if you understand why they are defined that way. And what implications they have on designing another database. So the kind of question I might give is something like, if I give you a diagram, give me an English description of what it means. Or maybe ask a more specific question like, can a student enroll in multiple classes if I gave you some diagram? Or the other way around. If I give you an English description, produce a diagram that represents that. What are the rules and why? So not just like many-to-many means create your own table. Why do we create a table for a many-to-many relationship? Okay, relational algebra. So this roughly maps to homework 1, homework 2 in phase 1. Relational algebra roughly maps to homework 3. Reasoning about queries, give me the answer, give me the result of this query, give me a query that does this, given some plain description. Differences between relational algebra and SQL. And then SQL will be homework 4. How do you give me a query that would do this? How do you create tables? How do you insert and delete from them? Things like that. Okay. So some high-level examples, like not a specific problem here, but something you can think about and imagine your own problems. So given some tables with various constraints. So I would say this column is a foreign key, this column is a primary key, things like that. I might ask you, like, is this instance valid? Is this a valid relational instance given those constraints? Or I might, so an example of that would be like, well, if you have duplicates in some column, it's not allowed to have duplicates. The answer would be no. Which of some English statements are true about this statement? So like, an X can have multiple Y's, or whatever. Okay, given some concrete instance of a relation, what will some relational algebra query return? Or write a query to return some description of what, some question. Okay, and then, so that's if you have an instance. What if you don't have an instance? What if you just have the schemas? So you can't query by instance. Write an RA query to find whatever. Okay, same thing for SQL. I might give you some instances, say write a query that does this. Okay, and then in an ER diagram, just be careful to watch out for terminology that has certain meanings. So there are lots of ways that a natural language does this, that English does this. You just have to pay attention to subtle things. What does at least one mean? What does at most one mean? What does exactly one mean? How do you translate that into cardinality and participation? Okay, let's do just a practice problem. We've already seen this ER diagram. This is some subset of some LMS. This is not necessarily our actual LMS. It's just a simple example. So translate this to students. First question. How many tables will there be?
4.
4. Why 4? Every entity set gets its own table. And which relationship sets get their own tables? Many to many. Okay? So, let's start translating this. Let's start with professors. Because it's easy. Prof has a column called UID. It should be non-null, and it should be primary key. We don't know its type. There's not enough information. If I wanted you to give the type, I'd give you more information. You could assume it's probably an int since it's an int. Okay, students is basically a copy of all of those properties. It has a UID, which is non-null, and is the primary key. Okay, let's do classes. It's going to have at least CID. It's going to be non-null. It's going to be primary key. What else does classes have? As a semester, we will call that non-null. It should be. What else does it have?
Plus UID.
It has a UID. What else? So what are the properties on UID? Non-null. Why? Double line means it's required. It has to be there. Any other properties on UID? Form key. Okay. Let's do the enroll. What properties does it have? It has a semester. And so it's that one. It's different than that one. It's not a problem. We don't need to disambiguate. It should be non-null. Is it primary key? No. Nope. Okay, what else does it have? UID and CID. UID is Non-null, both of them are. UID is a foreign key. CID is a foreign key. Primary key is both.
But we have to do software so that it doesn't matter which way, because you could have CID to UID and UID to CID and it'd be the same thing.
The order of the key doesn't matter until, well, for now it doesn't matter, until we start talking about indexes and the kinds of queries you would want to do on this table. It's a performance difference. The order of the key, whatever you pick, you do need to remember. If you use that as a foreign key, the order usually needs to be the same. There are rare cases where it doesn't, but it's weird if it doesn't. We won't talk about it.
Or the attribute like semester on the relationship thing, why does that have to be not null?
Why does semester have to be not null? There's nothing in the diagram saying that. It's just, in general, you pick not null for everything. The time where you do allow for null is, we don't actually have an example in this diagram, but it would be on a one-to-many relationship where participation is not required. I think I do have an example of that. But
Is there a way to make semester nullable in the CR diagram?
is there a way to make semester nullable in this DR diagram? Yes. We didn't talk about the syntax for it, though. Okay, I was going to draw those tables on this slide, but I just fit them in on the other. Okay. Yeah.
What would you use unique?
Where would you use unique? You would use unique after you've created the tables when you're doing primary key optimization. We won't do this whole thing, but we'll do just the games table.
Quick question about that.
Yeah.
So we did a one-to-many relationship and kind of showed how that doesn't necessarily need its own table. In most cases, it doesn't need its own table, right? What if it's a one-to-many with yourself? So what a single entity has a one-to-many relationship and it's not me.
So if it's a one-to-many with yourself, so like if this came back here or something.
Yeah. That T should have to be on the table, right?
So if a class can be taught by a class.
Yeah, it doesn't really make sense.
Well, what you would do is, it's the same way. You just put another column in there saying like, what is the other class that corresponds to that relationship?
But what if it's not mandatory?
And then if it's not mandatory, then you allow it to be null. Okay, just the games table. Translate to schemas. And refine the keys. So try to fit it on here. Games is going to have, start with the easy ones. It's going to have at least, thanks PowerPoint. I'm going to abbreviate too to save room. So round, it's going to have result, moves. What else is it going to have? How do we know what else it's going to have? It comes from relationships. So we have a one-to-many relationship here. We have total participation on all of them. We have lots of one-to-many relationships. So we need to pull in the keys from all of those relationships. Well, the keys from the entities on the other sides of those relationships. So we would pull in two names. We can't have two columns called names, so I will call them, now I'll call them W and V for white and black. Okay. We would pull in, know what? I do need to do this on with more room. Games. As round, results, moves, white, black, event name, site, and date. Those came from here. White and black came from here. But we have two of them because we have two relationships. Okay. Now the question of the attributes on these. All of them will be not null. So I'll just say not null for all of them. What are the, let's do the foreign keys. What are the foreign keys? White is a foreign key, black is a foreign key. And then all three of these in one are a foreign key. Why the difference? Why is white by itself a foreign key? Because the key itself is a single column. Name, site, and date combined are a foreign key because all of them are the key. The foreign key has to refer to a key. So you can't have it refer to part of a key. Okay, what is the primary key for this statement?
Well, if it asks us to refine it, don't we want to make it some game ID?
If it asks us to refine it, yes. So let's make the primary key first, and it'll be easy enough to change that and refine it. So let's not refine it first, then we'll do it.
The primary key is basically the round plus the other foreign keys.
It's the round plus all of those foreign key columns. Why? Why is, in this example, why is this foreign key not part of the primary key?
It's not a weak entity.
Because it's not a weak entity. Yes. Games is a weak entity, so its key is the partial key plus all of those keys that it holds. So we would get primary key, well, since the columns are separated, I'll write it this way. Primary key is round, white, black, name, ename, site, and date. Now, schema refinement, or key refinement, rather. All we do is convert that to a candidate key and make up a new one. The primary key is GID, game ID or something. So we would have to add a new column.
Could we, or would we want to go into the events table and then do something like that, where you
Yep.
make key names like J unique and then give it?
Yep. So if you were doing this whole thing, translate the whole thing to schemas and then refine the keys, you would refine this key down to a single column, and then you can just import that instead of name, site, and date. And that's like one of the reasons why we do this. It makes foreign keys much smaller.
Doesn't this kind of go against the design of the database? If we wanted it to be a weak entity set, why would we make it unweak, I guess?
Why would we make it unweak?
Yeah, because if you're adding another primary key, right? It makes
That
it
doesn't make it unweak. So doing this, I still have this.
Okay, so there's
This
a
uniqueness
unique key on
constraint comes from the weak entity set.
it. Alright.
Adding another primary key Doesn't change anything about uniqueness. All it does is I can now take this primary key and save it in like data structures and stuff in a much more compact way. It still represents one unique row, one unique game.
But we shouldn't be trying to show schema refinement in the ERD, right?
Right, you do not show schema refinement in the ER diagram. This is only because this problem specifically said, after translating to schemas, then refine the keys.
This question is kind of away from like exam study, but in like the industry, would you still have the ER diagram unchanged, even if people are going to be using it to try to navigate your table? Like,
Yes.
so like you wouldn't say, oh, we actually have a primary key.
Well, you can make two versions of the ER diagram. One showing just the basic requirements and one showing the actual tables. Okay, another. Modify this so that a game can be played without an event. So, like you could just pick up a game on a park bench somewhere and you're not at the World Championship or something. There's not quite enough information here. On a real test question, I would give you more details, but we'll just kind of start working through. There will be some questions that come up, like, well, what do you do with the remaining key and stuff? But how would we start? A game can be played without an event.
Remove the participation constraint and we can use that.
Yes, so first thing we need to do is that should not be required. And then if we have a non-required relationship, it can't be weak anymore. Weak entity sets have to participate. So we would start by making games just a strong entity set. And give it a single line with a single diamond. One second. And then, so that's the basic, what I wanted to get at with this question. But then the weird things that come up is like, well, what do you do with round? And that's where you would need more information to really answer this question. But the problem here is I've made that a strong entity set, so these could no longer be supporting relationships. So you'd have to decide what to do with those. You could make them non-supporting relationships, which would be fine. You'd have to figure out what the new key is. Maybe just make up a game key. But again, that's where I would need to give you more information. But this part here is just kind of what I wanted to point out for this problem.
Would it be reasonable to keep games weak?
You cannot keep games weak if you make this line non-required participation.
So it can't be weak to some things and not weak to others.
Oh,
Yeah.
actually, okay, yes, good point. Yep, you could keep games weak if you kept these as supporting. Yes, that would be one way to do it. What would that mean? That would mean the combination of round and both players has to be unique. What does round mean if there's no event? So again, it's kind of just a partial question. Okay, here is something from homework 2. This was a diagram with like the rooms, meetings. Here's the diagram that the question asks for. And then you say, let's modify this so that rooms can have the same, so multiple rooms can have the same room number, but not within the same department. So the original problem was, in the entire world, in the entire database, no two rooms can have the same room number. So that's why it's the key. Now they are allowed to have the same room number as long as it's a room from a different department. How do we specify that?
You could make a room a weak entity set and make manages a supporting relation.
Exactly. So rooms becomes weak, manages becomes supporting, and room number becomes a dashed underline. Questions on it? guarantee you, if I gave this question on a test, somebody would try to answer it by doing this. They would try to add a DID and combine it into the key so that room number and DID are unique. This does not solve the problem because there is nothing in this diagram. Well, if I erased this solution, now there is nothing in this diagram tying this DID to this DID. Those are just two different, completely unrelated things. So that's not how you do it. So don't be the person that answers it this way. Well, actually, the people who answer it this way are probably not here. So congrats. Okay, provide SQL for this. Kind of just an abstract ER diagram. It's along the same lines of like first you have to think about what does this mean in terms of schemas, but then go further and actually provide SQL. So we will create table. Ignore my capitalization. That C should be lowercase. Create table X. X would have A. We don't know the type. That's not a comma. A, we don't know the type. It's not null. B, we don't know the type. It's not null. Comma. Primary key. And this is not full SQL syntax. I'm just abbreviating for the slide. Primary key is A and B. Or B and A. Okay. Create table Y. It has at least C. We don't know the type, not null. What else does it have, if anything? A. Don't know the type. Not null?
Nullable.
Null. So this is where we leave off not null. Why? Because participation is not required. So it just has A, we don't know the type. It has B, we don't know the type. What is the primary key? Anything else? Yep, so foreign key, A. Shorthand, this is not full SQL, reference is XA. And same thing for B.
Shouldn't it be AB instead of? Yeah, shouldn't they be both in the foreign?
Oh, very good point. I just did it totally wrong. I just went over this. AB references XAB. Good. I mean, that illustrates the difference. You can't do them separately because a foreign key has to reference a key. They're not separate in the other table, so they can't be separate as foreign keys. Okay, this one. The only difference is that is weak, that is required, and that is supported. So I'll leave out X. The table for creating X is the same. So let's create Y. It's going to have C with an unknown type, not null. A with an unknown type, not null. That's one of the differences. Same for B. Primary key? All three. The order doesn't really matter, but I'll do C first since it's the partial key. Okay, and then the foreign key is the same. AB references X, AB. So the differences there were these not nulls and the primary key. How many, so I wouldn't expect you to like actually work this, like do these cross products and everything and work it out. There's a trick, obviously. How many rows in select star from patrons, comma phones, checked out, inventory titles? So first, remember comma just means join. So how many rows? You would not draw out the entire cross product. You wouldn't be able to.
You take the product of everything?
Yep, so 4 times 4 times 6 times 5 times 5.
Are you going to use a calculator?
Can you use a calculator? Yes. If you also just wrote down 4 times 4 times 6 times 5 times 5, also correct. Okay. What about this? How many rows in select author from? Same thing.
Same number.
Same number. This is where the difference between SQL and relational algebra is important. What if my query was project author out of inventory cross patrons cross all that stuff? What's the answer? 5 authors. Relational algebra always results in a relation, a true relation, which means no duplicates. Okay, I have a couple more. I'll put the slides online. We're out of time though for today. So good luck. See you next week.